Alright guys, here's the second part, and this is really kind of the meat and potatoes of this lesson. There should be a graph on your paper. We're gonna sort of do this the way we graph everything else. I want you to graph this function, f of x is equal to square root of x. I want you to get very familiar with that. It's called a parent function, just a basic square root function. It has the question, is it linear? And I want you to explain why or why not. Second question, are there any inputs that are not valid? We talked about that a minute ago. Are there any numbers you could not plug in here to make this thing work? Explain that one. And then we've talked about this a long time ago about domain and range. Talk about that briefly as well once we've graphed it. So you might be sitting there going, I don't know how to graph that. Mx plus b, vertex, I can't graph that. What's the most basic way to graph? And hopefully you go, oh yeah, a table. Anybody can graph with a table. My 2-year-old, no wait, my 2-year-old cannot graph with a table. But anybody can graph with a table. And of course we talk about easy inputs. 0, 1, and 2 are some pretty easy inputs. You might not want to go beyond that yet. So think about it. If you plug in x, plug in 0 for x, the square root of 0 is 0. That's easy. You plug in 1, the square root of 1 is 1. Simple. You plug in 2, and then you go, I don't know, this guy helps you. The square root of 2 is approximately 1.4. So we're going to graph these points. 0, 0, that's the origin. Over 1, up 1, that's the second point. Then something starts to happen here. 2 and up only 1.4. You would think if you're going, you went up 1 here and up 1 here. You went up 1 here, you go up 1. Oh, you didn't go up 1 here. You went up only 0.41. So this thing is starting to curve, it looks like. It's almost like a straight line here. And then it didn't go quite as high in the next one. I don't want you to put in 3 here. We're going to need some more points. I do want to put in a few more points. I've jumped to 4. You might know why. I want to try to get integers in here. I want to try integers values to make the graphing to be a little easier. So I don't have to use the calculator. And you should be able to graph one of these without a calculator pretty easily. So I'm going to plug in 4 because the square root of 4, if I input 4 here, the square root of 4 is just 2. That's an easy one. I'm not going to use 5. Square root of 5 is some decimal. Square root of 6 is a decimal. Square root of 7 is a decimal. Square root of 8 is a decimal. Square root of 9. What's the square root of 9? Duh, 3. So there's some points you can plot on there. I wouldn't use 10. I wouldn't use 11. I wouldn't use 12. I wouldn't use 13. Think about the next one I would use. 16. What's the square root of 16? 4. So I've got plenty of numbers here. 1, 2, 3, 4, 5. I got 6 numbers. I can plot these on the graph. Like we said, 0, 0 is at the origin. 1, 1. It's sort of, could be a straight line there. And then all of a sudden, I skipped the 1.4, but it'd be over here. If you plug in 4, you're only up 2. So it took a while to get all the way up to 2. So this thing is starting to curve. It's not getting steeper. Think about what's happened to the curve. The curve is getting flatter and flatter and flatter. And of course, 9, 16 is not even on the graph. It takes a while to get up to positive 4 for a y value, way out here past the graph on here. So, is it linear? Well, of course it's not linear. It's curving downwards. It says why or why not. You can explain that with the graph. You should be able to explain it with the table. And think about what's going on the table that makes it not linear. And of course that means that has to do with the steepness. It's decreasing. The graph is getting flatter. The change is not constant. A lot of you will say that. The change is not constant. I love people who word it that way. That's brilliant. Anytime during this lesson you can rewind. Anytime during this lesson you should certainly be encouraged to pause it and kind of think about some of these questions on your own. Talked about this a few minutes ago. Are there any inputs that are not valid? Are there any x values that don't exist on this graph? Hopefully you go, well, duh, the graph doesn't go over here because you cannot plug in a negative number. There's no way you can plug in a negative x value and get a real answer on there. So there's the first thing. And why can't you? Well, the negative square roots don't exist. This question is closely related to that. This is a pretty good look at the graph. If you think back to domain and range, domain is basically the x values. It's all the x values that exist. So this is a list of terms, but it also includes the decimals that are in between these. So think about the absolute smallest domain or smallest x value you can have. And of course you go, yeah, it's 0. You can't go down here. Think about the absolute biggest x value you can have. That could be infinity. I mean, that's going to keep going over here. It can be as big as I want for an x value. So it's basically everything from 0 to infinity. The domain, the possible x values, are simply values greater than 0. You'll see it often written like this. X is greater than or equal to 0. 0 is included in that domain. Do the same thing with range. Range is the y values. What's the smallest y value you can have either in the table or on the graph? And of course, it's a different reason, but it's the same thing. You'll notice the graph does not go below here. If you think of where this curve is going, it doesn't go below in the negative values, because when you take a square root of something, you're always going to get a positive value. And now, we talked about plus or minus square roots last. Sorry for the shaking on there. Plus or minus square roots. It doesn't apply when we're graphing just a basic function on here. So the range of this thing is only y values bigger than 0. So domain is x values, range is y values. We'll talk a lot about domain on homework and preceding slides on here. So here's one to crank out Desmos and explore with Desmos a little bit. I'm not going to go through this with you. I have nothing to show you on here. Graph these two functions. Explain what happens when you have a constant subtracted from within the radical. It's important that you type this in correctly and play with it. The radical should go over the whole thing. You might have to use parentheses on Desmos. I kind of doubt it because Desmos is pretty slick. And then the second question, when you add some positive value here instead of a negative value, what happens to the graph? Do a bunch of these. You don't have to just do these two. You should be learning from this activity. If you're just filling in papers and writing garbage down and you haven't learned anything, you're not even realizing how valuable Desmos is. Learn something from it. You should learn more from that than you should from me talking. So if you haven't learned something when you read these two questions, you're not playing with Desmos. Play with it. Play it like a game and figure out what the heck happens when you add or subtract numbers inside the radical. You'll see it shifts the graph in some interesting ways. And then do the same thing when a number's outside the radical. And again, you might have to play with Desmos to get it to work this correctly. Square root of x minus 2, square root of x plus 5, and again, the plus 5 is outside the radical. You could type this in backwards if you want as well. You could do 5 plus the square root of x, or negative 2 plus the square root of x if it's hard to do it, in this sequence. And then, think about what happens when this k value, what does this do to change the location of the graph. These are really easy things to observe if you play with Desmos and mess around with it. I think they should be pretty simple conclusions to draw, but they're important ones to understanding the graphs. Now, when you're ready for it, we'll get back to this last part. I'm going to pause this for a minute for the last part.